Welcome to H2M's design presentation for SDSU Capstone 2020. My name is Hannah Birch and I am the project manager. I will be discussing later the design of the Learning Lab.
I'm Holly Hayes. I designed the Decentralized Wastewater Treatment Plant, also known as DWATS, and assisted with the Learning Lab and water reuse design. I will present our DWATS design.
Hello everyone, my name is Martin Valero Casas. I was the lead AutoCAD drafter and performed the hydraulic analysis for our project. Before we talk about the main part of the project, I'm going to introduce the project purpose and overview. San Diego State University is creating a new 172-acre campus by redeveloping the 132-acre San Diego County Credit Union Stadium property. The campus master plan will incorporate a decentralized wastewater treatment plant that will provide the campus with recycled water and a hands-on learning lab for students. The learning lab will be located in Building B2 on campus. Building B2 will be located on the southwest area of campus, and it is the best choice for the learning lab because it is the closest in proximity to the sanitary sewers serving the campus that will receive waste from the learning lab. Now I'm gonna pass the conversation on to Hannah, who will talk in more detail about the Learning Lab.
We have designed a modular wastewater treatment laboratory offering students hands-on learning and research opportunities. This lab offers typical lab features such as lab workbenches, fridge and freezer, and a fume hood, plus more that will enhance the learning experience for wastewater research. As a part of the lab, we have designed several lab-scale wastewater treatment systems. There will be an activated sludge treatment that will be constantly running through the lab. It begins with the holding tank that is being filled with wastewater from the building and stirred to ensure no sedimentation occurs here. Next, we'll see a suspension tank where the operator can change the incoming wastewater characteristics by adding chemicals or other additives. Then the wastewater will pass through the sedimentation tank seen here. This tank will be designed to have the option of adding lamellas if needed. After the sedimentation, the water will run through the activated sludge system where it will be aerated and stirred. The final effluent water will move into a collection tank where it can be sampled or pumped back into the sewer. Next, you will see the modular part of our lab, which starts with the holding tank and then sedimentation. From the sedimentation, different modules will be able to be connected. These modules will be on carts to make it easy to interchange the treatment processes. Here you can see the trickling filter module on its cart. Each cart will have a collection tank at the end that can be sampled from or sent back to the sewer. Now, going back to the other side of the laboratory room, you will be able to see the other two designed treatment modules. On the left side is a lab-scaled sequencing batch reactor, and on the right is an anaerobic treatment process.
The decentralized wastewater treatment plant is located below ground on the south side of the building. Wastewater enters one of three sequencing batch reactors, or SBR. When the SBR fills to 5,500 gallons, it will begin the treatment process. The conditions in the SBR will change using aeration and mixing to achieve nutrient removal. By adding and removing oxygen, the conditions are optimal for bacteria to convert ammonia to nitrogen gas through denitrification. Similarly, phosphorus accumulating bacteria uptake the phosphorus, removing it out of the wastewater and allowing it to be reabsorbed into the sludge blanket. After 6 hours, the clean affluent water is decanted to the ultraviolet unit that disinfects the water to Class A. The water is then sent to 4 unique water towers located throughout campus, like the multicolored glass and Aztec football towers you see now. The water is then available to irrigate 20,000 square feet, 5 buildings with green rooftops, and support multiple water features, saving SDSU $24,000 a year and reusing 390,000 gallons of water.
In conclusion, we have designed an innovative and user-friendly system that requires minimal maintenance that will make SDSU pioneers in urban wastewater treatment and will put researchers on the cutting edge of technology. On behalf of everyone at H2M, we thank you for your time and we look forward to seeing you on Design Day.